Hello everyone, and welcome back to FOSS, our course on open source software. Today's topic is open source in software products, or more specifically, open source governance for software products. By that we mean the practices, processes, and practices of properly including open source software as parts of software products. For that, let's quickly look at this term governance, usually combined with compliance. Organizational governance, meaning we are now talking about software companies or companies in general. Governance is the way the rules, norms, etc. are set up to lead to desired actions, behavior of people or the whole organization. Compliance means not only the rules, but how to make sure that they are being followed. So that meaning that people are compliant to those governance rules and practices and processes. Within organizations, there's all kinds of governance going on. For example, in the software domain, there will certainly be security governance rules. Sometimes there's also financial. Most certainly there will be financial governance and compliance, the rules that govern anything with respect to financial transactions within the company, etc. Of interest here to us is open source governance and compliance. And so that specifically is then the governance or how a software organization or how an organization in general still manages its open source engagement. In the following, I will always say governance, where I actually mean governance and how to make people comply to that governance, the compliance. As a heads up, when I say compliance here, I'm not talking about license compliance as we discussed it in the session on intellectual property. License compliance are the rules of how to comply with open source licenses. Here, compliance in the context of governance means how to comply with the governance rules. Of course, license compliance will be part of governance, but open source compliance to the governance is a larger, different topic. Anyway, so as we have discussed, we have a small maturity model of engagement with open source software, and it consists of using, contributing, and leading, creation and leading of open source software. Now here we are almost exclusively concerned with using open source software and products, and also a little bit with contributing, opportunistic contribution, and not at all about any strategic engagement or leadership, which will be the subject of later sessions. So we will be talking about open source in products and services. So I just want to quickly add that here. In the following, I will always say products. By that, I mean regular software products or any product that includes software, but also services to the extent that they have been cast as products. Software as a service, meaning some software that you subscribe to and pay for through the web, is, in my opinion, a specialized form of product. You may not necessarily have an upfront license fee to pay, but you do pay your subscription fee and you get a standardized product delivered to you through the web. So service providers of this kind of software as a service are really product software vendors, in my opinion. In both cases, the software licenses apply. Specifically, we now have a new generation of software licenses, most notably the AGPL version 3, which specifically address products delivered as services through the web. So in the following, I will simply say product, and I also mean software as a service. So why would software vendors and service providers actually use open source software and products? Well, the usual better, faster, cheaper applies. In the first iteration, open source components are simply high quality components. Also, they're immediately available. There are just no hurdles to using them. You just download them and start using them. Finally, they are free, so there's no license fees, so they're as cheap as it can get. This is also how most people find their way to open source. The focus is on cheaper, high-quality software for free. Now, that is the motivation of saving costs, and then follow some other benefits. For example, open source is available for inspection. You can help yourself fix bugs, so you don't have to rely on a third party, a vendor, a supplier of yours, where it may take quite some time to get a problem fixed. So again, that makes open source faster than closed source software. Because there is no supplier that you're locked into, the software is also faster from an innovation perspective. You can provide your innovation yourself. Finally, open source software is often standards compatible and sometimes even is the reference implementation and thereby defines compatibility with a standard. So you can use it and it's of high compatibility to whatever you need to be compatible with. Now, the real motivation, though, for using open source software in products, in my opinion, is simply you will be developing better software, faster and cheaper, because you can now focus on what is important to your business. Open source software is not competitively differentiating, hence you need to get that software done as quickly as possible, as high quality as possible, and rather than doing it yourself, you use it from the web, and that allows you to focus on what is most important to your business. So open source software, using it, frees you from having to deal with things, frees you to some extent from having to deal with things that are simply not competitively differentiating. So knowing where to use open source software versus where to do your own development means you understand the value proposition of your business. There's maybe one downside to using open source software, which is that is the issue of security, because the software that you are using can now be analyzed on a source code level. There may be additional attack angles for any attacker, because using static and dynamic analyses, they may get a bit further than if they were applying those same analysis, say, to bytecode or machine code. Also, not using open source is not really an option. I still sometimes hear companies tell me, we don't use open source software. Now, whenever I hear that, first of all, I usually don't believe it. Engineers pressed hard for time are prone to use open source software if it fixes their problem. It's good quality software, often available for free, so why wouldn't they use it? It may just not be that the engineering management of the company knows that or believes that any veto on using open source software is actually being followed, which of course may be uncertain. But most importantly, it means that if some company is not using open source software, it's doing all the development themselves, or it's paying for components, that it really can get better and cheaper as open source software. So that company does not have its business focus straight, because it's obviously spending more time than is necessary on things that are not competitively differentiated. So if it was exchange traded, if it's a public company, I would dump any stock I had. All right, so we need to talk now about governance, meaning again, how to get open source into your products in a safe and efficient way. For that, any company should set up some sort of program office, sometimes also called competence center. I'm not sure why in Germany they tend to be called competence centers, Maybe that's just very path dependent how these terms come about. Maybe program office to some is simply the next step after a competence center, because you want to have a strategically led a program, open source program. And so that is also the first thing to understand. Open source is the business of if not the CEO, then the vice president of engineering or the CTO. And they should establish an open source program office, but they should set the goals of open source use themselves, and they should maybe develop them in conjunction with the open source office, but the open source office is ultimately who gets tasked with achieving those goals. So what then is the open source program office? Well, it's the first point of contact for all things open source within the company. It has to manage the governance process itself, and as well as any particular governance processes. The difference being a governance process is, for example, clearance of an open source component. Can we use it or not? That's a governance process. But the governance itself would be, what are our strategic goals? How do we measure that we achieve those, etc.? And that again is something to be done in conjunction or led by the vice president of engineering. All right, so the goals of open source governance in general are pretty much the same wherever you go. There are particular strategic goals that companies want to achieve while they engage with open source. And then they want to avoid problems they might run into. And of course, do all of that efficiently and effectively. So these goals are typically, again, saving costs. That is how companies start. But ultimately focusing on the business, spending your time and resources where it matters. So that leads to governance processes, meaning those rules and practices and processes of how you achieve the governance goals. And so here it would be, for example, that you would need a process to identify the opportunities for using open source. If you don't even know that you should be using open source software, then you are not going to do it, and it will just happen purely opportunistically. You need, if you have as a goal to focus your business on value generating tasks, then you need to have a process going where you identify when you should be using open source, which is where any use of such software component is not competitively differentiating, meaning you're not going to do it yourself. Anyway, so if you have focused business first, then you identify what components you need. If you don't have that, developers by themselves may propose something. So you need to have a process of selecting and approving open source components for use in products. And then you need a process for inclusion, and you need a process for managing these investments. This is actually the most basic set of steps or a large-scale process run in product companies. How to identify what you need, how to find it then based on those criteria, how to include it, and how to manage your dependency now. And all of these processes really are somewhat complex processes with lots of sub-processes, etc. And good governance will get these processes right. They will be led again by the program office and be carried out by the program office in conjunction with the product management and software development. These general goals are often then, so here we have them. What does it mean? Identification of open source opportunities, that's the product manager with the engineering manager, identifying them, selecting them as the engineering manager and the software architect, leading components through the clearance process. Including them means, for example, you have to modify your product architecture document and bill of materials, for example, to achieve license compliance later on, and ultimately, again, manage your open source investment. So you're tracking those projects, you're watching out, say, for security holes. you know when to engage with the project. These strategic behaviors, on which I was a bit fast perhaps, are usually, sadly, if you will, only the second step that companies take towards good open source governance. I thought it was important to bring them up front because good governance, of course, is structured strategically top-down. While most companies find their way to good governance only by realizing, or somehow we are already using open source components and we need to rein that in. We need to get a handle on something that got out of hand. And that is usually the case because companies have been using these components and they run into the legal problems, for example, by not complying with the licenses and finding unwanted code in terms of unwanted licenses in their products. So they have problems and they set up governance to manage these challenges and avoid the problems, and only later do they find their way to what should have been the initial step, which is to set up a well-structured, strategically directed top-down governance. Anyway, because even today dealing with the problems is so prevalent, I want to discuss it in more detail because for students, this means this is what you'll be running into once you leave university and rejoin or join for the first time a company. So the challenges with using open source software are manifold. Most people will think about the legal challenges resulting from copyleft licenses and patents, software patents, but there are also quality challenges, most notably around security, but also other quality challenges, and process challenges are keeping your product aligned with the open source software you depend on. So let's look at these in a bit more detail. Legal challenges is what's on most people's mind as they try to rein in the use of open source software. Specifically, the problems that perhaps there is copyleft licensed code in your products, which if it became apparent and someone came asking for you to be license compliant, you would have to provide your source code, which most companies usually don't want to. So here is the cause and effect chain that leads to those unwanted situations. So first of all, if you don't have good governance or did not have governance for a while, then there simply may be behavior by developers like copying and pasting code from the web or including libraries without clearance. That is problematic in that it leads to a software for which you're not behaving in a license compliant way, meaning you have copyleft license code in your product, but you're not aware of it, or you're not following license compliance rules, and you're just delivering it to customers as if it was proprietary code. So that is a potential problem, because if it comes out, if it becomes known, then the potential problem might materialize, and companies might get sued. So first of all, perhaps threatened with a lawsuit, but pretty quickly also possibly then subjected to a lawsuit. And if there are merits to the lawsuit, well, it will most likely lead to an out-of-court settlement, because that's always cheaper than fighting in court to the end, typically. Or if you actually fight to the end, it will lead to losing in court. So let's take a look at how this actually comes about. It would be helpful to understand the legal situation here. So these lawsuits can be based on a variety of things. The most common one is the copyleft license-based lawsuit, meaning a copyright violation. You are not complying with the license, or the company is not complying with the license, and hence it does not actually have a right to use the copyleft licensed code, and thereby now the copyright holder of the code can, well, basically sue you for not being complying with the license, but then possibly provide an alternative settlement. Anyway, so here's the steps. Here's how the legal drama plays out. The software vendor develops a software, CP here, which includes copyleft licensed open source code and provides that software to a customer. A copyright holder, who may be the customer or may collaborate with the customer, makes the customer realize there's copyleft licensed code, and hence, and if it's combined in such a way that it can ask for the source code from the software vendor, well, then the customer will ask for the source code. Now, the software vendor does not properly react to that. They may get sued, simply because they may not want to provide the source code, and hence they now find themselves possibly in court, etc. And from there on, it's probably headed for an out-of-court settlement. So the violation here is that the software vendor doesn't know what they're doing, includes copyleft licensed code, delivers it to a customer who then gets sued or is also the copyright holder, and then the copyright. If the customer is so the customer is the one who has the right to ask for the source code. So that's why they need to collaborate with the copyright holder. All right. So the patent situation then is one in which the we have use of open source software again in a software product provided to a customer. And here now the open source software incorporates some patent, some algorithm that is owned by a patent holder. And if this becomes apparent that the software has been used, that the patent has been used in some software, a patent holder will first sue any customer of the software vendor, because it's the customer who's actually using the software with the patented algorithm in it. And hence, the customer, first of all, is facing the unpleasant situation of a threat of a lawsuit, because typically the patent holder will ask for license fees first before going to court. But the customer, since they purchased a license from the software vendor, will use the clauses of the license, the warranties, etc., and indemnification of the account that they received through the license to turn over basically the problem to the software vendor. So the patent holder will ultimately have to deal with the software vendor. So this is how the how patents are a threat to the use of open source software. So in both cases, the vendor might find itself in court, and that has all kinds of unpleasant consequences: high legal costs, reputation loss, certainly time loss, resource loss in the form of wasted management attention. If it actually goes to court, then the software vendor may be forced to disclose confidential information as part of the proceedings that they may not want to disclose. So there's competitive information being dragged out in the open to the competitive disadvantage of the vendor. Now, if there's a need if they need to, so ultimately they have to settle, or the court will come to a conclusion. So in the case of settlements, there will be all kinds of financial costs associated with it, paying license fees, paying the lawyers to the bitter end. Also compliance costs, making the software comply now with the discovered requirements of copyright or patent rights. And if it gets really bad and they lose in court, the vendor loses in court, not only do more fees accrue, but in the worst case, until things have been fixed, it may lead to a sales stop. That's actually the worst possible thing to happen for the software vendor, that the plaintiff is able already perhaps during court proceedings to stop the sales of the software because it's violating the plaintiff's rights. So that would mean significant product revenue loss potentially for the software vendor. In addition, and there's the usual then compliance costs, but also the increased risk of more lawsuits. So in any case, if it's a copyright case, the software vendor now needs to get compliant with the license, and that means having to rework the software in case they are kicking out the unwanted code, or they have to and they might have to purchase some third-party closed source software, so that creates more fees, or they may have to lay open their source code, which they absolutely may not want, of course, and hence they might be losing their intellectual property because it's not available under a certain license, under probably a copyleft license, and thereby they also reveal much more again about the architecture, strategic direction, etc. That's available from studying how the code has been developing. All right, so but how do all these things come about? It's not that companies want it. It just somehow happens, apparently, without governance. And here is an illustration of how it could happen. The software vendor responsible for a product incorporates other parties' code in various ways. Other parties or third-party code here is code to which they don't hold exclusive ownership rights. And that could be, for example, an open source library that they simply include as part of their product. So that's an engineering decision to use a particular utilities library, something like it, and they include the library and how now it's part of the code base of the product. That is a fairly visible thing to happen because the library itself will be recognizable as such. But also it's possible that a developer looking to solve a problem simply goes to some open source code on the web and copies and pastes it into the source code base, marking it literally as their own development, even though that's not true. So next to an explicit inclusion of a library, say through some build files, there might also be a copy and paste that makes it into the code base by a regular commit, making it harder actually to track down that intellectual property mix-up later on. Also, a company may of course license some third-party software from a supplier, so they simply pay some supplier for what they probably believe then is a closed source software component. Now you may argue that smart developers know what they're doing, meaning they include a library that's not harmful, they copy code from the web only in such a way that it's not harmful, and if you license or if a company licenses software from some supplier, well, then they can set up the rules in the licensing contract that make things work out the way they want to, ideally. But just because it says something on the outside of a package doesn't actually mean that this is what's also inside the package. So even if, say, an open source project has a permissive license, who guarantees that the developers of that open source components properly followed good open source governance rules and did not mix up themselves in a lower tier here in the supply chain, mix up their own code base with other licensed code. So if an unwitting developer of the product copies and pastes copyleft code into the product, the same could happen with an open source component developer who copies over code from some copyleft project into its own permissively licensed project and not tell anyone. So even if you may get a handle on the first tier as a software vendor, You don't know what your suppliers have been doing, and they might have been creating the same problems that you are trying to get a handle on by not following good governance themselves. That applies as much to a closed source software vendor as it applies to a regular open source software project. So it's really multiple steps how copyleft licensed code, as the usual example of a problem for a software vendor, makes it into the supply chain of components to the final product. So how likely is it that even if there is such a license violation ultimately, how likely is it that you get sued or that a company gets sued? Well, at present there are two sources of lawsuits, and they're the so-called GPL enforcers, also philosophers if you will, and the GPL monetizers who are in it for the money. The philosophers or GPL enforcers simply believe that software should be free, and hence they fight for software to be set free, or at least for software to be license compliant. And perhaps the main component or the most visible way of how this is being organized is by way of a nonprofit foundation, the Software Freedom Conservancy, which raises funds to support copyright holders in suing software vendors for freeing the source code that those software vendors provided to customers. And so this has led to a couple of high-profile lawsuits, mostly or often around Linux because of the GPL version 2 license, and with various outcomes. So a few times actually companies have prevailed in being able to claim and sustain that the source code, that their use of copyleft licensed source code did not constitute a derivative work, but in other cases they have also lost and companies had to settle and fix their problems. These philosophers, if you will, or these GPL enforcers, in the best case, they just want companies to be license compliant, which means lay open the source code or remove the copyleft licensed code, hence so that there is no license violation. The other phenomenon are the GPL monetizers, and in this case it's people who are actually in it for the money. So they literally shake down software companies if they can for their not license compliant use of open source software. And so this is literally a business model similar to German Abmahner. You will receive, if one of those copyright holders, usually of the Linux kernel and somehow very often of the networking stack and so IP tables and netfilter, if they learn that you're using Linux and netfilter, then you may receive a request to lay open your source code because it's copyleft licensed code. If you then don't comply, these guys may get more aggressive and go to court. The trick here is usually that the first attempt is lightweight in that the company simply agrees to not do it again and pays a small amount of money for the license violation. But then, in conjunction with this, and I only know the German term here, strafbewährte Unterlassungserklärung, meaning the agreement by the vendor not to do it again. The vendor often doesn't realize how many of these GPL challenges they have in their products, and hence the copyright holder, once they receive the Unterlassungserklärung, will turn to the company again and hit them with all the other violations of the licensees, extracting this time significantly more money from them. So in any case, these are ongoing proceedings in various courts. It's hard to learn anything because usually these guys settle out of court and don't make public any proceedings of it. It's obviously neither something that the plaintiff wants to be known widely, it's a good business for them, nor the company who's suffering from these challenges. All right, so open source governance directly affects the product, and in the worst case could lead to a sales stop of your product, which is about the worst thing that can happen to a company because its revenues are being cut off. Now, having good open source governance thereby becomes the responsibility of the CEO. Because it is so important, it's critical, because also we now believe we know how we are doing it, how to do it, which is good governance, as explained in this talk. And hence, if companies don't have good open source governance, it's actually the CEO who will be on the hook, or in German, it's Geschäftsführerhaftung that applies, because you cannot wriggle your way out of it. It is now considered a best practice or a state of the art to have good governance. All right, so here, tidbit more of industry information. The patent lawsuits are less common, or they are usually not open source specific. One way of how companies are trying to protect themselves is by joining forces with mutual agreements to not sue each other through because they all need to share in a patent pool. Also, some open source licenses these days have patent retaliation clauses, meaning you lose the right to use some open source software if you enforce a patent against someone else using the software or some other open source software. There are different variations. And the first one, most notably the Open Invention Network to protect Linux, works well among, or seems to work among industry participants. It doesn't work, of course, against patent trolls, which are companies that exist solely to extract money through patents and who don't have any other viable business. The patent retaliation is another tricky thing that the open source community has set up, or it's kind of ingenious. So let me shortly illustrate that here. You have some, so there are variations of it. Let's assume it's a patent retaliation clause in the license of some open source software for use of specifically that open source software. So here now, there's a software vendor 1 and a software vendor 2 who are both using open source software in their products. And some were, if it's popular open source software, in often the many products these software vendors have, there'll be a use of these open source software components. Anyway, so the software vendors use these components, and now software vendor 2, who owns a patent that has been implemented in the open source software, sues the software vendor 1, who is also using this software for, say, license fees. They want to receive license fees. Now, the clause in the open source license says that anyone who is suing for patents as related to this particular piece of software loses the right to lose the software. That's the retaliation. And hence, as soon as software vendor 2 would sue software vendor 1, they would lose the right to use the open source license, because now they are not compliant any longer. And this way, the patent retaliation clause protects users of open source software to some extent from getting sued for patent violations as they pertain to the open source software component. Anyway, so if all of this sounds daunting, well, it's basically no risk, no reward. There are the initially framed benefits of using open source software and products. It comes with these legal risks, and good open source governance makes sure that these risks remain manageable. That's the purpose of governance that addresses these problems through proper processes. So here are a couple of governance processes to deal with the legal problems. Obviously, educate your developers. If necessary, refresh the education, make it easy to look up things, provide good guidance so that they know what they can and cannot do with open source software. Most critically, most organizations set up a clearance process where developers know they have to go to get approval for using an open source component. Such a clearing process will then involve multiple parties that deliberate on a particular component and whether the license is acceptable to the company and the way it's embedded is will work out without unwanted legal consequences for the software. Also, into this category falls managing of your suppliers, where you need to communicate to your suppliers the acceptable licenses, so meaning the open source software your suppliers can use in their products. You may ask them to provide a bill of materials, a list of the things included, things like that. These are deep and rich topics that I can't cover in much detail here, but that I'll be happy to talk about later on the site. Rather than go through these processes in detail, I want to show students some tools because that makes it a bit more plastic, visual, approachable. And so open source software or the open source world has led to the creation of various helper tools in software development to make sure companies know what they're doing when they work with open source. So at some point of time, there's usually a first step into open source or into reining in open source software use, and that usually means that that part of getting started of good open source governance means taking stock of your portfolio of products and what open source software is in there. There are actually good open source tools that help you do that. You see a screenshot here, the free and open source software Fossology, which will scan all your files on your hard disk, so from your code repository, and if they identify license files from well-known open source license, they will tell you about it. So you basically get a basic inventory of say that GPL licensed code has been used, or here or other licensed code. So in this example here, you can see most files have no license associated with it. Some have Apache, but there are 2 cases of the AGPL version 3 are included in this example. Well, that's of course an indication for taking a closer look, analyzing the context, and possibly taking action in terms of removing source code of licenses that you don't want to be compliant with. Fossology is a free tool, so it's open source software. There's even a database that's available for free, but it's been aging. The challenge here is that, of course, in order to recognize open source software, Fossology only relies, in the example at least, on recognizing license files. So there's a limited number of license files, so those can easily be scanned for. More importantly, though, is what about all these lines of code that might be copy and pasted into any software project? Well, for that, there are more tools, other tools. It's actually a viable business. Scanning tools, for example, that will scan your source code and compare it line by line with any open source code that is known from the web. So such scanning tools can be applied when you're getting started to take stock, take inventory of your source code. It can be embedded in the development process. For example, before any developer is allowed to commit to a source code repository, the source code scanner may check that code for whether it's actually an assumed copy and paste from the web. So Here you can see such a tool in action. It's performed a scan. I think this is Black Duck, Protex software. It has scanned the source code, and it will provide and found something, and it will show you the original open source code so you can compare it by hand with that open source code. The reality of these tools is that they provide a large amount of false positives, simply because the companies themselves that want to give you these tools don't want to be held liable to missing anything of significance. So usually the settings are to show more rather than to show less, and that of course means a fair bit of work then for the first time working your way through all these findings and selecting them and confirming them, or possibly rejecting them as users of open source code. Once you have set up basic open source governance, you'll want it to be a bit more efficient. So now a typical best practice would be to provide a repository of acceptable open source components that have passed clearance, and hence you'll provide a centralized repository inside the company where everyone can go and download approved open source components. Here, Open Logix Repository Manager, download those components and basically short circuit the approval process because they're using pre-approved component. Now, this is what happens within the company. Ideally, these components you get from your suppliers, and you should count open source software projects as suppliers, are clean and clear, but of course they may not. So open source projects need to start caring as to what's included in them. And while you may think, well, why would an open source project care about its users? Well, as we will have already seen and will see again, most of the open source software development these days of commercially important projects is actually being done by professional software developers. In any case, lots of companies are now pushing to open source projects and beyond to have a bill of materials using some standard, here the SPDX standard, basically to provide a component inventory with associated metadata as to what's included in that particular software component. After all, it's usually a large tree of components that include components that include components. And so we now have some sort of industry standard which is trying to track what is inside of an open source component, and can also be used for closed source software components. So any company may want its closed source software suppliers to also provide these standards. And in fact, there it's easier because, well, you have a contract with that supplier, as opposed to an open source project where you have no contract. Okay, so these are legal challenges. These are some tools for best practices and processes of good open source governance, etc. Now let's look at some quality problems with open source, most notably potential security problems that we are facing with open source software. Open source software can be scanned on a source code level, so it may be easier for an attacker to find security holes, because not only do they have access to the binary, or in case they have it, they now have access to the source code, which may make tools more effective. So there are more options for finding vulnerabilities. But this means these vulnerabilities don't get disclosed, which is probably, even though we just had cases of government agencies hoarding vulnerabilities, is perhaps not the most prevalent problem. The most prevalent problem is vulnerabilities that are known, that have been made public and that have been fixed in the open source components, but where the companies are using the old versions of components which do not yet incorporate these bug fixes. So if companies are using old vulnerable versions of components, and they actually show signal to the world, for example, by posting on the mailing lists of open source projects that they're using these components, it may become apparent to an attacker that a particular vulnerability may be in the products of this company's products. So how serious is that? Well, here's a way of finding it out. The central repository is the Maven repository, or the repository of libraries used by the Maven build system provided by Sonatype. And so Sonatype has a lot of data on what components are being used in software development by Java, but also other software developers around the world. So first of all, the central repository, Maven Central, is huge. They had, in 2015, they had 31 billion component downloads. But they also know which version of a component companies download. And so they know that 6.1, not shown on this graphic, 6.1 of those components being downloaded had known security vulnerabilities that had already been fixed, but people were still downloading the old versions. And that led to 6.8 components and applications that have at least one known vulnerability. So actually the phrasing here is incorrect. In the report it says that 6.8 of the applications in a sample they looked at had known vulnerabilities based on vulnerable out-of-date open source components. So 1 in 16, that's pretty serious. And this of course is then subject to good open source governance. What do companies need to do? Well, they need to monitor the open source components they're using in their products. So they need to identify that there are vulnerabilities that became apparent because it was published a new vulnerability to these components they depend on. They may not passively wait for it. They may want to have bounty programs so that people are actively looking to find bugs, so you don't risk so much or risk less that some agencies are quietly hoarding vulnerabilities. Once you learn of a vulnerability, you need to determine your exposure, determine removal cost, carry it out, and update, of course, your customers or your services with a fixed version. There's much more to be said here, but this then falls into a security lecture and not so much an open source lecture. Once we know that an open source component is a source of a vulnerability, we switch to security issues. But what needs to be covered here by good open source governance is that open source components and products need to be monitored for vulnerabilities that become apparent in their products. All right, so next to these legal challenges and quality problems, specifically security problems or potential problems, there are also process problems with using open source software in products. Specifically, these open source projects with many customers or many users, if you will, don't really quite care too much ultimately. Well, okay, that's wrong. Open source projects do care about their users, but they have many, so they can't make it right for everyone. So they need to basically first act in their own interest and then typically try to broadly address needs. So products, closed source products or whatever products, need to be aligned with the schedules of the open source projects. Now, if the open source project understands that its infrastructure not competitively differentiating, it will, if it's smart, have a predictable schedule and ideally a regular schedule where it's predictable when a new release will be cut, assuming that the product using the open source component wants to jump from stable release to stable release. But it's open source, so there's just no guarantee that the particular feature will be in there, but at least a regular defined schedule makes it more predictable. So that is somewhat manageable. More of a problem is if a product company is developing software that ultimately, say because of a GPL license or copyleft license, will have to be open sourced upon first delivery to a customer, but it doesn't want to do open development. So it develops in a closed source, in a closed setting, and then tries to dump, say, a new Linux kernel driver onto the community, which of course is hard to swallow. This is a typical problem specifically with Linux, where, say, the developers of gadgets don't want USB gadgets don't want the world to know what they're working on. It would be visible from the software development if they were to carry it out in the open. But then once it's done and once they release their little USB gadget or whatever, once that is done, they want to get the source code into the Linux kernel if there are changes necessary or what have you, or released and maintained by the community as soon as possible, except that, thinking back to how engineering processes and project communities work, it's really undesirable to receive a large dump of code, because how do you know that it's of high quality? So there's a constant strain between, in particular, the Linux kernel community and hardware manufacturers who need Linux drivers incorporated with the kernel. But these are already somewhat specialized problems. The more general problem is that a company is using some open source component and finds a bug and fixes it. So now they have a maintenance problem if they are not contributing that bug fix back to the project, because every time there's a new component version, they have to reapply the fix. So a smart developer will want their code, their bug fix, to be applied to the main project where it gets maintained and evolved, so that they only have to merge it into the main line once and never again later on, because it now comes automatically with each new version of the component. Now, this form of contributing back of bug fixes or maybe small improvements is highly problematic from a company perspective, because clearly you are signaling to whoever is looking that your product, or at least this company, is using this open source software. That's a signal to competitors, for competitive intelligence, that you are saving costs by using these components, with all kinds of ramifications, including the discussion on security. It's now apparent which components you're using, and if there are known security vulnerabilities and you're using an old version of the component, well, maybe then the software is vulnerable. And but it's not just security, same thing with legal. If you're actually contributing to a copyleft license code, well, you're probably using it. So now we know you're using copyleft license code, and the next thing some GPL monetizer will do is to look at your license compliance. Are you complying with the license? And if not, you might have a legal problem at your hand. All right. So how serious is all of that? Well, again, schedules, well-run open source projects will have a predictable schedule, will cater to their users' needs. So I think that's manageable. New function development is also manageable. Depends on the context. Ideally, you can do open development rather than closed development. The maintenance problem, contributing back small scale, can also be fixed. If you have, first you need appropriate governance. And so let's take a look at how this governance could look like. You need a review process for contributing to open source projects, where you define a point of contact, where you define criteria for should you contribute this back or not. And you may even hide that it's you or your company who is doing this by hiring outside people to act on your behalf. This way you can hide your involvement or your engagement with the open source project if you so desire. All right. So these were, in the beginning, achieving a strategic goals, but then mostly dealing with problems that open source could bring to your doorstep. And the third point of good open source governance was doing all of it at minimal cost, which is another way of saying that you want to be process and resource efficient. And for that, you need that program office, again, with clear roles and responsibilities. You want to provide as much self-help as possible so that developers know how to help themselves and make speedy decisions. Again, governance is a big topic. Here's one way of looking at it by domain and the processes that people carry out. So we have governance itself. We have supplier management as a major component, engineering management, product management, etc. And for each of these process areas, there are people who play roles that define their engagement and their responsibilities, the practices they carry out, the results they produce, etc., etc. The way I prefer to look at it is as a process and practice handbook, which usually starts with defining key roles. What's new here is really to understand that you probably need that program office and then some program officer to run that program office, who is responsible for enacting governance. And the other important thing to know is that it's a C-level, a top-level responsibility, so the CEO may delegate the governance work to the program office, but they nevertheless still have to set the strategic goals. So the CEO is the guy who tasks the program office with its job. And in the early stages of an open source governance program, typically the legal counsel will be important because mostly it's the legal threats that companies see. But over time, that will diminish and the legal counsel will be one of many working with the program office. The others are, of course, the product managers, engineering managers, software architects, and developers, who all are involved with the governance processes in one way or another. The way I like this best, and this is how we work as a research group on open source governance, is to have a handbook of processes and practices, best practices. Here you can see a small excerpt, figure, screenshot for some process areas, the clearance process or approval process, supplier management, provision of a component repository, etc., all of which are further substructured into a garden variety of best practices that are carried out as part of the large-scale processes being run by the program office. In order to do this, and the way we do it is for it to be easily consumable by software developers, engineering managers, legal counsels, etc., who use our handbook and make it their own for the company. And the way we do it is by setting up best practice descriptions. So we have processes described as workflows, and we have best practices, which we describe using a triple of problem, context, solution, similar to the way design patterns have been described in the past, or patterns in general. And this gives us small snippets of validated experience in an abstract form. In fact, I'm mentioning this because this is how we sometimes structure the homework for the FOSS course, as an exercise in understanding the practices of open source software development and structuring them into such best practices, for example, for governance. Here's an example of how one such best practice could look like. This is taken from ensuring license compliance as part of product delivery to customers. So way down there among the other practices, you will find something like generate compliance artifacts. And it's the product manager's ultimate responsibility. And any of these practices, including this one, has a context. So previously, you determined all the compliance artifacts as they relate to the product artifacts that are being included as deliveries. And you need to provide the compliance artifacts next to the actual product. So the solution to how to make sure you're legally compliant here is to include all the compliance artifacts, generate them for that. You generate them from the sources and include them with the actual product deliverable. Here's another, a bit earlier, perhaps, but not equally less important practice. Manage your suppliers. This one is an overview best practice. You can see by the arrows and words in italics that other best practices are being linked to. So this overview practice basically manages or is an entry to the process area of supplier management. And here an engineering manager is tasked basically with how to deal with suppliers from an open source perspective, and it collects all these sub-best practices, if you will, like requiring a governance certification, if you wish. This is still in the future, but then allows some auditing, perhaps for some governance maturity, so you know your suppliers know what they're doing when it comes to open source. All the way to you're getting a delivery. Now you need to review that delivery. Did they include a bill of materials? So you require they have a bill of materials, etc., etc. The details don't matter. This is simply an example of how we capture best practices as part of a handbook of processes and best practices for good open source governance. It's usually such a handbook is usually structured top down. So here you have supplier management as an example, and the various best practices as they're being carried out while companies enact their open source governance processes. All right. Finally, at the end, a short quiz on the organizational structure. Where would you put this open source program office in the organizational structure that I talked about? Into product management, engineering management, into the legal department, or make it independent? Well, to make it short, most companies will first put it into the legal department, where longer term it certainly does not belong, because the legal department's goal is to prevent bad things from happening, while the program office job actually is to make sure good things happen. So ideally you make it independent. That's why maybe in Germany it's often also called a competence center. So that's it from me. In this session, we looked at what is open source governance, what are strategic goals, what are challenges that it needs to address, and how to be efficient. We looked then at how some of these, just using examples because the topic is so large, how some of these governance processes and practices could look like and could be codified such that it's easy for companies to pick them up, and for that we chose a handbook form. That's it from me again. So thank you very much for your attention, and see you next time.